Thank you all for coming. My name is Ben Burgess. Today I'll be presenting work we did on remote proctoring software called Watching the Watchers. So I'm sure everyone has seen over the last 10 years, we're starting to see rapid adoption of remote learning environments and moving away from these more traditional in-person environments. And through this, institutions have been looking for ways to ensure that they have exam integrity in these remote environments. So we've been seeing more and more adoption of remote proctoring software. And through this, we've seen tons of articles that come out that say, students of color are getting flagged their teachers because testing software can't see them, along with this general usability problems for the student. And this is really underscored by how high stakes these exams are. They're generally kind of the capstone exam, for example, like the bio exam or things like that you need to take to actually enter the field. We build our work on examining the examiners, which looks at the student experience concerns around remote proctoring. We do a little bit more of a technical deep dive into these suites. So to start, we wanted to see how prevalent these exam suites were. So we focused on law schools because they're generally, again, high-stakes exams where you only have a few of them and they account for most of your course grade. So we went through and we collected usage statistics from the top 180 ABA-accredited law schools. And then we also focused on bar exam associations because you need these to actually enter the field as a lawyer. So once you finish your law school career, your law school, you go and take the bar exam and then you can become a lawyer. We collected these through emails, calls, open records requests, and scraping public websites. What we found is that there was 3 main proctoring suites used by law schools: Examplify, Exam4, and Electronic Blue Book. There was some other ones like Canvas and MyLaw, but those were a much smaller percentage individually. For the bar exam itself, we see, again, 3 main ones stand out: Examplify, ILG Exam 360, and Exam4. So the main question that comes from this is, do these software suites actually prevent cheating, or is it just all security theater? And what we're going to focus on here is not as much the motivated adversary and the very experienced adversary as much as just kind of the evil law student and what they would be able to do to bypass the security features. We can break down the security features these suites offer into 3 main ones: exam content protection, session monitoring and restrictions. So this is to serve as kind of like what a in-person proctor would do. So monitoring what content you can open, and kind of restricting that, and then providing an audit log after the fact. And then finally, we'll talk about identity verification. So in order to do this, what we did is we obtained the binaries for Examplify, Exam4, Electronic Blue Book, and ILG Exam 360. We reverse engineered these, and then we took our findings and kind of our general methodology, and we tried to generalize these, and we designed an automated tool from that, which will allow us to hopefully support future studies where they can build off of our work. So if we look at what an evil law student might do, they would want to potentially get the exam ahead of time, right? And encryption at rest tries to prevent this, because normally what happens is you'll download your exam, let's say 3 days or a week ahead of time, and it'll just sit on your computer. And then when you go to take the exam, you're given the password for it, and you're able to open it. We see general pretty good encryption algorithms being picked here, so most of them are using like AES-256. But the question from there comes, is the system around that actually being used securely? And what we find is that that's really not the case. So several of these exam suites will use HTTP connections in their backend to the server. And even if they're using a secure algorithm, it doesn't really matter if your key derivation process isn't secure. And Examplify in particular uses very few password derivation iterations. So what this means is if you didn't have a very long and secure password, someone would be able to easily brute force this. An Electronic Blue Book actually uses a fixed password salt called kosher. And by having that fixed and so simple, you'd be able to just pre-compute a lot of these passwords. So now let's talk a little bit about session monitoring and restriction. This can kind of break down into 3 main categories. So you have your process restrictions, clipboard restrictions, and then your virtual machine and device prevention. The virtual machine device prevention works to support the process restrictions and clipboard restrictions, because if the software suite can't see your whole computer, then you're not really able to enforce any of those restrictions. So they make an attempt to prevent that. So let's see what we found here. We see that almost all of the proctoring suites implement some form of virtual machine detection. This normally takes the form of a block list. The same with the virtual device detection. What this means is that anything the developers didn't think of is permitted, which is just insane there. So if you have a suite they didn't think of, you could run that, or if you were able to change the name, you'd also be able to run that. And then if we look at the process restrictions, we see them change it up a little bit here, where we move to an allow list for some of them. And this is just a pre-approved list of applications that they allow you to run. And that seems like it would be a lot better than a block list, but that's again until you look at how the system works. Once you do that, you figure out that they're not checking the digital signatures for any of the proctoring suites. So, sorry, for any of the applications. So you'd be able to easily rename applications to bypass the restrictions that they put in place. And some people might, from a CS background, kind of question, why do we even care about the clipboard, right? Like, what are you going to copy and paste in? It ends up for law exams, a lot of the answers you normally have are based on large blobs of case law and other things. So a student can obtain a massive advantage over everyone else if they're able to quickly copy and paste this in. But it ends up that you can just get a USB rubber ducky, load in your essay or whatever case law you want, plug this in during your exam, and it can easily bypass all of the clipboard management we saw implemented. So you don't even have to mess with virtual machines, right? And now finally, let's talk about identity verification. This is particularly important because, okay, these suites are like completely security theater, that's fine, but if they don't harm the user, why do we care? Let them use them, right? But identity verification is where we can start to see the main effects on the student and the main negative impacts of the adoption we're seeing around remote proctoring suites. We picked Exemplify for this analysis because they do most of their verification client side. So they run the facial recognition models in the software. They do two specific modes. One is initial verification. So what this does is it acts as a gatekeeper. So when you want to try to begin your exam, you have your ID and some trusted picture, so like your student ID or something like that that they can reference, and it takes a picture of you trying to begin the exam, does some comparison operation, and determines whether or not it thinks it's you and whether or not you can start the exam. And then continuous verification just works to make sure that if you pass this initial verification step, you're the one who continues to take the exam, and you don't just have someone immediately swap out for you. So you'd think, given that this is working kind of as a gatekeeper, right, and could prevent people from even being able to take an exam altogether, that they would have picked the best, like, state-of-the-art algorithm, done extensive testing, make sure it's fair, right? Well, what we found here is they're using an unmodified open source model they just pulled from GitHub called faceapi.js, along with dlib, and this is being used for all of their verification operations. So in order to discuss how this performs, we need to first have some metrics we can use to talk about what performance means in this context. So we're going to talk about two here. One is the false non-match rate. So what this means is if you had a subsequent image of yourself, would the software think that that is actually you, or would it say that's not you? You can't take the exam, right? Go contact somebody. And this essentially means the student is being accused of cheating. And this might not, I mean, this may seem fine, okay, just go talk to somebody, but you have to remember the stakes here, right? These people have, this is either at the end of a semester or at the end of your law school, like a law student career. This is like the gatekeeper to either being able to graduate or being able to be a lawyer, right? So they're already very stressed out, and this is just another bar. And then we also have false matches. So what this is if you have a subsequent image of a separate person, would that be identified as being you? And this acts as a proxy for whether or not a student would be able to potentially cheat and get away with cheating by having someone else take the exam for them. So what we find here is that we see pretty high FNMRs across the board. 0.66 may seem somewhat low at first glance, but if you think about a 1,000 student class, this means 6 people would likely have difficulty taking the exam. And if you've ever been on a Zoom call or like a Meet call, the images we have here on the left have controlled backgrounds that we're testing with, controlled lighting conditions. This is much better than you would probably see in the field. So that is a very optimistic FNMR. And when we move out to the in the wild data set, VGG phase 2, which uses varied backgrounds and things like that, we see this raise up to 14%, which would be about 140 students in that 1,000-person class. Additionally, if we look at the false match rate, we see that that's around 21%. for the controlled images, which suggests that even in optimal conditions, this is merely security theater. It's not really providing much actual security to the process. So now that we've established that this doesn't really work well overall, we can look more at the fairness question and see if we're actually seeing bias in this. Is it being unfair between people from different races and things like that? So to do this, we collected data. We used data sets that have racial classifications in them. We understand that race is more nuanced, and our labels here lack nuance, but we were using the ones from the original data set. So we went with that versus trying to reclassify. What we see here is significant variance between subjects of different races, with in some cases, for example, on VGG Phase 2, Face API had a 7% difference. So over the 1,000-person group, that would be 70 students. And you would expect that, given all the stakes and that they know the software is going to be used as a gatekeeper, that they would pick a project that didn't have known errors around this, right? But if we go back to 2019, there was an open issue on the repo that they used that states, the author directly stated that there was a bias towards Western faces that they were aware of in the classifier that Exemplify then went and chose for their software. So what we've established here is that the software is nearly universal. We found that it can't meaningfully prevent cheating from a technical perspective. It's mainly security theater, so it looks really strong, but it doesn't actually do too much for you. And there's significant overall usability concerns with it. The facial recognition doesn't work well overall, and it has additional fairness components. So this really leads us to the question of, should this software be implemented at all? And based on our research, we don't think that there's any place for this software in production environments. Thank you all. I'll now take questions.